Hi, my name is Son, and my announcement subject is antioxidant intake improves pulmonary function. This announcement is based on epidemiological studies. Let's get started. Introduction. This picture is that antioxidant-rich food. Antioxidant-rich food can improve pulmonary function. Accumulate evidence suggests that dietary antioxidant vitamins are positively associated with lung function. This finding supports the hypothesis that beta-carotene and vitamin C and vitamin E may play a role in respiratory health. The objective of this experiment is antioxidant, especially vitamin C, E, and beta-carotene intake improve pulmonary function. Next is materials and method. This study reports the data from a general population sample drawn from an area in Niagara countries in New York State between September 1995 and December 1998. A detailed description of the study design, participant recruitment, and methodology has been reported. Study population. In brief, New York State Department of Motor Vehicle and Healthcare Finance Association list were utilized to randomly select participants aged 39 to 79. Final remaining 1,616 participants are included in this report. Excluded participants for whom information was available were comparable with the included participants in the distribution of gender and race and were similar in their mean age, height, weight, dietary antioxidant intake, and total energy intake. However, excluded subjects had lower levels of pulmonary function and education were more likely to be smokers. And next, examination. The examination included an in-person interview about lifestyle habits, a self-administered questionnaire, anthropometric measurement, and spirometry. Spirometry was performed between 6:30 and 9:30 a.m. according to 1994 American Thoracic Society guidelines. We then used multiple linear regression to derive FEV1, FVC prediction equations for men and women. And next, nutrient intake. We assessed user diet over the 12-month period starting 24 months before the interview and the 12-month prior to interview for each participant using 100-item health habits and history food frequency questionnaire. Less than 5% of participants reported intake of carotenoid supplements in the 30 days prior to the interview. Because of small number of carotenoid supplement users, we did not calculate carotenoid intake from the supplements. For vitamin C and E, we collected information on regular supplements used with food frequency questionnaire, and we repeat the analysis for vitamin C and E, adding the intake of these two vitamins derived from supplement. All nutrient intake are expressed as daily consumption. Finally, statistical method and analysis. To define statistical significance, we used the conventional level of p-value under 0.05, but determined that interaction terms would be significant if the level of significance was p-value under 0.1. We investigated interaction by including interaction terms of antioxidant vitamin intake, smoking status, and other covariates. For the analysis, we utilized the statistical package for social science and S+ software. Next, we got result. You can see the table 1. You can see the standard deviation and mean, so you can see easily know about scatter diagram. This table 1 shows the characteristic of study participant. The average age was 59.6 years, and based on the mean body mass index, participants tended to be overweight. The sample included a slightly higher number of women than men and a small percentage of African Americans. Approximately 43% were never smokers and 13.7% were current smokers. Intakes of nutrients were within expected range, and almost one-fourth of the participants reported daily supplementary vitamin intake. Next, table 2 shows the mean FEV1% and FVC% by quartile with vitamin C and E. After adjustment for other covariates, for each of antioxidant vitamins, pulmonary function was higher in the upper quartiles compared with the lowest quartiles. We observed the greatest difference between the bottom and top quartiles for the antioxidant vitamin C and vitamin E. And next, table 3. You can see the table 3, and table 3 summarizes the result of multiple linear regression analysis after inclusion of all covariates. Multiple linear regression of FEV1% revealed independent associations with past years of smoking history, smoking status, education, eosinophil count, and weight. These variables were included in the baseline model. FVC% was associated with past years of smoking history, weight, and education, but it showed no statistically significant association with eosinophil count and no additive effect of smoking status after we included past years of smoking in the baseline model. For the analysis of dietary variables, models were also adjusted for total daily energy intake. We observed a statistically significant association of vitamin C and E with FEV1% when we added these variables individually and separately to the baseline regression models. Next, you can see the table 4. Table 4 shows regression coefficient for the significant antioxidant variable when we included all statistically significant variables simultaneously in the model. Although for FEV1%, vitamin E was the only significantly correlated antioxidant variable, we observed no statistically significant interaction of antioxidant intake with smoking. However, because of possible effect modification of smoking on pulmonary function by nutrient intake, we performed the analysis separately by smoking status. You can see the table 5. Table 5 summarizes the finding when vitamin C and E were added separately or simultaneously to the regression model for never, former, and current smoker after adjustment for confounders. When we added variables separately to the models in never smokers, vitamin E were significant correlates of FEV1 but not vitamin C. No antioxidant variable shows a significant correlation in former smokers. We observed the strongest correlation for all variables in current smokers, but the regression coefficient was not significant for vitamin E. When we added variables simultaneously to the baseline model stratified by smoking, the antioxidant vitamin failed to reach statistical significance, while the coefficients for vitamin E were similar compared with the other models. We observed the greatest reduction in the regression coefficients for vitamin C in all smoking strata. And you can see the table 6 shows the regression coefficient for the important dietary variable by smoking status when we added the variables individually or simultaneously to the regression models. The antioxidant variable was significant or borderline significant correlation of lung function in never smokers when we added the variable individually to the baseline model. As for FEV1%, we did not find significant correlations in former smokers when all antioxidant variables were added simultaneously to the regression models in all smoking strata. Vitamin C and E were not statistically significant. Yeah, you can see the discussion. Discussion is a little bit like summary because this experiment is epidemiologic. So we skip this summary. Then what we can discuss about this experiment, we can know about the vitamin C, vitamin E, and beta carotene intake improve pulmonary function, but other antioxidants like alpha carotene or others also can improve pulmonary function. We can think about this. Yeah, thank you for listening and have a good time.